Okay, so the second physiological variation that I'm going to be talking about is the increased afterload. The increased afterload can occur due to hypertension. Anything that will increase the aortic pressure can represent as afterload. Okay, and so what does this cause? What this causes, like, it's going to cause an increase in the left ventricular pressure to open the aortic valve, right? Because in order to open the aortic valve, the left ventricle is required to exceed. That means having a greater pressure than the aortic pressure. Okay? So that represents here on point C to D. That's how normally it is. But an increase in afterload will deviate the D prime into D, which is a little bit higher. So in other words, this is the isovolumic contraction, right? This from C to D represents the isovolumic contraction, where there's no change in volume as the pressure increases due to both valves being closed, right? That is the mitral and the aortic valve. And so as you can see, it's a little bit longer. That means the time is going to be increased, right? The isovolumic contraction time. And so that's the first thing that can be observed. The second thing that can be observed occurs at point F. What does point F represent? Well, it represents the aortic valve closing, right? And so in this case, we see that it doesn't go all the way here. That means it's going to close sooner, right? So early closing of aortic valve. And that can be represented as this change right here, right? From F to F. And what would that involve? So that just involves the end systolic volume, right? That is the amount of blood left at the end of contraction, right? Or ejection. Contraction, ejection are the same. And so that can be seen in point A, down here, because that's at the bottom. We see that there's less amount of volume from A. As you can see here, that's less, right? Because now we have a new point, the point A. And so when there's an increase in stroke volume, and systolic volume, that means that there's going to be a decrease in systolic volume. Again, if we look at the simple formula that says that stroke volume equals the difference between end diastolic volume with end systolic volume. If you increase this, you're gonna minimize the change, meaning you're gonna make this decrease. Okay, so to recap, increased afterload will produce an increase in end systolic volume, which can be seen as a decrease in stroke volume.